Hello, students. Hello.
Yes, sir. Good afternoon, sir.
Good afternoon.
Good
Screen is
afternoon, sir.
group.
Good afternoon, sir.
Only one person response. But
Good afternoon, sir.
screen is visible. Hello.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Today discuss the mu test. Yesterday in the last class we have discussed the comparison test, but today we discuss the mu test for improper integration of the second kind. If fx be an integral function in this range, where epsilon is a positive number and greater than a and less than b minus a, and a is the only point of discontinuity, then a to the fx converges provided limit of x minus a to the power mu fx extends to a plus 0, since a is the lower limit. So we consider x tends to a plus 0 is equal to L, and if mu lying between 0 to 1 and for converges a non-zero finite number and mu lying between 0 to 1 and diverges if mu greater than or equal to 1. So this is the mu test for second kind improper integration. And for first kind, that is, the range is infinite, either one or both. Here upper limit is infinity, and then in this case we assume fx is bounded and integrable in a to x, where x is less than infinity, capital X is less than infinity. Now if there exists a number mu greater than 1 such the limit of x to the mu fx extends to infinity exists and equal to a non-zero finite number, then this is convergent. Non-zero finite number. If there exists a number mu less than or equal to 1, provided limit of x to the mu fa extends to infinity exists and is a non-zero finite number, then this is divergent. The same is also true if this tends to infinity or minus infinity. In the case of lower limit, or also in the both case, minus infinity to plus infinity. Now this problem we have already studied, and this is a problem for mu test. This is mu test. Consider problem x square dx by 1 plus x square whole square. Yeah, this is an improper integration of the first type. Upper range is infinity of the first kind. That fx is equal to this, and gx is equal to, remember that the highest power of x is in the numerator is 2 and the denominator is 4. So we write, but take gx is equal to x square by x to the 4. Clear? The highest power of x to the power highest power of x in the denominator is 4. So we take x to the 4. It is equal to 1 by x square. Now taking the limit of fx by gx extends to infinity is equal to this, or dividing by x to the 4, it will be this is equal to 1. If we take x tends to infinity, so that 1 by x square tends to 0 and it will be 1, a non-zero finite number. Therefore 1 to infinity fx dx and 1 to infinity gx dx have the same nature. Now 1 to infinity dx by x to the mu is convergent for mu greater than 1. Therefore, this is also convergent for mu greater than 1. Here, hence 1 to infinity this is convergent for mu greater than 1. Remember that here mu is equal to gx. This is convergent for mu greater than 1. Gx. So this is convergent. Now, in the case of gx, 1 by x square, so mu is equal to 2, which is greater than 1. So the integral converges. To evaluate the integral, we use the transformation x1 tan theta in another way. It can be integrated, the value is this or this or this, pi plus 2 by 4. Since it takes the finite value, so the integral converges. This is another method. Actually, this is the high secondary. Very simple integration by putting x1 tan theta. This is the verification. Apply new test to examine the convergence of this. Here I is equal to this, it is also of the first kind, improper integration. Take mu is equal to 2 because here the power of x in the numerator is 1 and that in the denominator is 3. So it will be 3 minus 1 is equal to 2. So we take mu is 1, 2. And taking the limit x to the mu, this x tends to infinity. The limit of this is equal to 1. Dividing by x cube, it will be 1 by x plus 1 whole cube. So it will be 1 as you take the limit x tends to infinity. It is also a non-zero finite number, and since mu greater than 1, it is convergent. Apply mu test to test the convergence of this. Now this is an important one of the second kind. Since the range is finite, although x is equal to 0 is the point of discontinuity, infinite point of discontinuity. X is equal to 0, sin 0, 0. Take fx is equal to this, and we take mu is equal to half. Why it is half? Because if we write in this way, sin x by x into 1 by root x, this can be written as sin x by x into root x into sin x by x. Okay, so root x sin x by x can limit as x tends to 1, as x tends to 0, sin x by x limit 1. So it can be written as root x by sin x means 1 by root x into sin x by x. But the second part limit is 1 as x tends to infinity, 0. So it will be 1 by root x. So mu is equal to half. Taking x to the mu fx, x tends to 0. So limit of x by sin x, x tends to 0 is equal to 1. A non-zero finite number. As mu lying between 0 to 1, it is half. 0 to 1, so it is converted by definition. This is very good problem. Test the convergence of the integral -1 to 1 dx by x. Here, there is an intermediate point 0 at which the function is unbounded, 1 by x. So this is improper integration of the second kind. 0 being the infinite point of discontinuity. Here fx is equal to 1 by x, -1 to 1, range, fx 1 by x. So if we integrate, actually -1 to 1 can be written as -1 to 0, 0 to 1. This can be split up two parts, -1 to 0, 0 to 1. But in order to find the by value of the improper integration, we take, this is 0 minus epsilon. But in this case 0 plus epsilon dash. Here we take epsilon dash may be equal or unequal. Unequal case it is more general case. But epsilon lying between 0 to 1 and epsilon dash is also 0 to 1. Then taking both the limit. Now this is a log x, it is also log x. So this is equal to log of epsilon by epsilon dash. The value. Now we see that the choice, if we take epsilon 1 3 epsilon dash, then answer will be log 3. If we take epsilon 2 epsilon dash, the answer will be log 2, not equal to log 3. So you see that there are so many answers. So the integral does not converge. And it is so many answers. If we take epsilon is equal to 3 epsilon dash, particular answer log 3. If we take 2 epsilon dash, it is particular answer log 2 and so on. So the integral is not unique. And so the given integral does not converge. And it has no value. If we take epsilon is equal to epsilon dash, then it will be 0, since log of 1 is equal to 0. So the value is 0. Thus, although the general value, when epsilon is not equal to epsilon dash, then that integral is known as the general value. Cauchy general value. The Cauchy general value does not exist, although principal value exists. Principal value means when epsilon is equal to epsilon dash. So this problem is very important. So we see that while you tackle the problem, there are two ways. One is principal value, another is general value. General value means epsilon not equal to epsilon dash, and principal value means when epsilon is equal to epsilon dash. Here we see that principal value exists and value 0, but general value does not exist. So this type of problem you may try also by replacing -1 to 1 dx by x cube. dx by xl cube. So you may try another problem. It is of the same nature. That is, principal value exists, but Cauchy general value does not exist. Replacing x by xl cube. But if you take x cube, x square, x to the 4 even power, then it always converges. This is very good relation for gamma beta function. And gamma relation, gamma n plus half is equal to gamma 2n plus 1 root pi by 2 to the power 2n gamma n plus 1. Now gamma n plus half is equal to gamma this is equal to gamma 2n minus 1 by 2 plus 1 is equal to, we know that gamma n plus 1 is equal to n gamma n. So this is n gamma n. Again replacing this in this form, it will be this and ultimately this gamma half. But we know that gamma half is equal to root pi, already this proved in the last class. So the final answer will be this. Now multiplying the numerator and denominator by 2n minus 4, 2n minus 2. Remember that only the odd number are present. So multiplying by even numbers, starting from 1 to 2n. And you will get, this is the numerator, this is the denominator. The numerator, this will be gamma 2n plus 1, 1, 2, 3, 4, dot, 2n. So gamma 2n plus 1. And this will be taking 2 common, 2 to the power n into 2 to the power n. So n into n minus 1 dot 1, that is factorial n. Factorial n means gamma n plus 1, when n is integer. Similarly, this is factorial 2n is equal to gamma 2n plus 1. So this is the result. Gamma n plus half is equal to gamma 2n plus 1 root pi by 2 to the power 2n gamma n plus 1. So this is very important result. So you must, this problem is very important for the examination purpose. So be careful and study how it can be proved. The above result can be written in the form, another form, same result, another form. Assuming gamma this is equal to pi cosec m pi, 0 less than m less than 1, this a and b and number 2. So 3 problems. 3, 4, 5 problems. Now gamma 1/3, gamma 2/3 means gamma 1/3, gamma 1 minus 1/3 is equal to pi cosec pi by 3. Applying the result, this result, m into m minus 1, pi cosec m, put m is equal to 3. So this m is equal to 3, is equal to pi 2 3 to pi by root 3. Again this is equal to, you can rearrange this in this way. 1 by 8 by 9, 1 minus 1 by 9, this, and applying the above result, you will get this value. As we know that cosec pi by 9, 2 pi by 9, 3 pi by 9, 4 pi by 9, you have studied in Hasing the course. And its value is 16 by 3, and ultimate value 16 pi to the 4 by 3. For problem 2 means this, put x square is equal to sine cube, sine square theta. X to the power 6 is equal to sine square theta. X to the 6 sine square theta. So it will be 1 minus cos square cos theta. Cos theta to the power 1 by 6. And 6x5 is equal to this, putting this cos theta 1 by 3 and this one, that is this one. Now replacing this in this form. This form is already discussed in the beta function. This is for beta function. And beta mn is equal to gamma n by gamma m plus n. Now 1 by 6, 5 by 6 means 1 minus 1 by 6. So again applying the same relation. Gamma m, gamma 1 minus m is equal to pi cosec m pi. Putting this value, is this value or pi by 3. Gamma 1 is equal to 1. Similarly, 3, I1 this, I2 this. Now I1 is equal to, this can be written sin theta to the minus half cos theta to the 0. That is, so this can, in terms of beta mn or gamma function, this by this. So for part 1. And for part 2, sin theta to the half is equal to this, is equal to this. So applying the gamma function, you will get this value, and ultimately this is equal to I1 into I2. So writing this, simplifying, you will get value gamma half a whole square is equal to root pi whole square is equal to pi. After simplifying. And last one, I is equal to this, I1, I2. I1 a similar problem. same as problem 3. This I2 is equal to this, multiplying I1, I2, value is again same value 5. So this is all the problem. This problem is very important. This problem is very important. And this problem is very, very important. Example 11. You again try for this problem, minus 1 to 1 gx by x cube. Same result, same procedure, and answer is the same. Would you discuss the mu test and some problems of gamma beta function?
Sir, I have a question, sir.
Well, tell me.
Sir, what's the syllabus of mid-semester?
Actually, there will be a meeting before commencing the mid-semester. After taking the decision, I shall tell you.
Okay, sir.
Another?
Excuse me, sir.
Okay, tell me.
Sir, what is the syllabus for maths for mid-sem?
Sir, please tell us as soon as possible because it's today 31st January and from 14 February is the exam, sir. Please give us some time to practice.
I hope within 4 or 5 days there will be meeting in our department. After taking the decision, I shall tell you. Okay?
Okay, sir.
Normally, after taking the decision, after it is possible, after taking the decision, after the meeting, after holding the meeting. Okay?
Yes,
Sir,
sir. Yes,
what in our syllabus we got from institute website, there are 6 serial and there is written that first half is serial number 1, 2, 3 and second half is serial number 4, 5, 6.
Yes, first half, second half, yes.
Yes, sir. Then is it the mid-semester for first half?
No, for final semester. It is for final semester. Mid-semester, there will be no part, only one part.
Okay, sir. Because, sir, there are 3 teachers who are teaching us maths, sir. One madam is, sir, teaching us differential equation, sir. You taught us improper integral. And sir, another teacher is, sir.
And also infinite series.
Yes, sir. Another teacher completed infinite series, single real variable, and he is continuing that integration part.
Yes. This part means improper integration.
Yes, sir. You are teaching us improper integration, but another teacher, I mean, without expect the madam, he complete infinite series, single real variable, and function of several real variable. I think.
Oh.
Differential, small error. These are going on.
Infinite series, I have.
Sir, infinite series you have done.
Sir, yes, infinite series only you have taught.
Only I am.
Yes, sir. Yes, sir.
Actually, there will be no common part. Okay.
Okay, sir. Okay, sir. Then, sir, out of 6 chapter, here is 4 already done or doing, sir. These 4 are the syllabus for mid semester.
Possibly that.
Okay, sir.
Sir, that is too much for mid-sem.
See.
4 chapters.
Normally, after taking the meeting, after holding the meeting, I shall take the decision and then I shall tell you. Okay?
Yes,
Sir,
sir.
please tell us that. Yes, sir.
Okay.
ओवर हो गया
चला गया बढ़ो
सर, चलेगा।
मैं तो अभी आया था।
सर हो गया भाई, मीटिंग करो।
सर कहाँ है सर आप?